Hello everyone, and welcome to Math 1. Today we're going to be looking at some basic functions and looking at graphing specifically. So, today we'll be learning how to find the domain, find the range, find the zeros, find the y-intercepts, find intervals of increase and intervals of decrease, find max and min values, identify end behavior, and today we'll specifically be looking at f of x equals x squared. So, graphing it, we just have a basic f of x equals x squared graph. You can see it has a point at 0, 0, at 1, 1, at 2, 4, etc. So, let's talk about the domain and range of it. So, the domain of a function are all the x values that you could plug into it. And so we can see with f of x equals x squared, we have no restrictions on the domain. And so the domain would simply be negative infinity to infinity. And we use the parentheses here instead of brackets because we know we could never get to infinity. We could always get closer and closer and closer, but we couldn't quite get there. So what if it was f of x equals x squared over x? So we have f of x equals x squared over x. So I would guess most of you guys would immediately see a problem with being able to plug in all values in this because of this right here. We have an x on the bottom and we all know that we cannot divide by 0. So we would have to exclude 0 from our domain. And so how do we do that? So we start off with negative infinity to infinity. That's our domain when our function is just simply f of x equals x squared. And so we have negative infinity to 0 because we know we cannot include 0 in our domain. And so we use another parenthesis here. And then we have 0 to infinity. Running into my graph a little bit there. So let's talk about the brackets versus parentheses real quick again. If you have a bracket, that means you do include that number in your interval. And if you have a parenthesis, that means you are not including that in your interval. So, we have that right. And so there's the brackets and parentheses. Alright, so the range are the y values which come out of a function. So if we look at f of x equals x squared, we know that when you square a number, you always come out with a positive number unless it's imaginary. And we don't really work with very many imaginary numbers in this situation. And so f of x equals x squared always has positive values. So what would our range be? Since we know it's always positive, we would start off at 0. Then we go to infinity because we know it will get closer and closer to infinity, and again without it quite reaching there. So we have that parenthesis. And we have the bracket with the 0 because we know we could plug in 0 for the x value here. And so we would have to include that 0 because 0 times 0 is 0. So we see we get that right. And so what if it was f of x equals negative x squared? So we have f of x equals negative x squared. Okay, so what do we know about this? Since we knew that x squared was always going to be positive, we know that negative x squared is always going to be negative. So what does that mean for our range? We know that it could go all the way down as close as it could possibly get to negative infinity. Then it could go all the way up to 0. There's no range for that. See, we got that right. Alright, finding zeros. So zeros are when the graph intersects the x-axis. So that would mean that that's when y equals 0. So in order to find zeros, we have to set the y value equal to 0. And so let's try this when f of x equals x squared. So f of x equals x squared. our zero value of x. So 0 equals x squared. And so we know the only way to get 0 when you square something is for x to be 0. So we have a 0 at x equals 0. Alright, get that right. So what if the function was f of x equals x minus 5?